Points P and Q lie in a plane with PQ equals 8. How many locations for point R in this plane are such that the triangle with vertices P, Q, and R is a right triangle with area 12 square units? Okay, so first I want to consider the scenario where PQ is a leg of that right triangle. So I'm just going to draw a line segment, call it PQ, and I know it's got to be 8. Something that's going to be true about this triangle is, so I know the area of the triangle is 1/2 base times height, which equals 12 from this problem. Let's say, I know the base is going to be 8 because I'm saying it's going to be a leg of that right triangle. And now it's just about finding the height. So I know the height has to be 3 from solving. So right here, it's pretty clear to see if I just draw a line up like that, here's 3, I can draw a right triangle like that. Here's point R. And I can actually do that in 3 other locations. Right here, there's the right triangle. Down here is another point where R could be. There's a right triangle, and these are all height 3, and right there. So where PQ is a leg, there are 4 options. Now let's consider the case where PQ is the hypotenuse. So in this case, I'm still going to draw PQ, but it's going to be the hypotenuse. And I want you to notice that, so if I draw this dotted line with height 3. So let's just assume, so first I want to notice that right here, when R is right there, do you see how that angle, this angle, since this is a right angle and that's an acute, that angle's got to be acute. It's got to be less than 90. So now that you've got that, you know that. Let's consider the very middle point right here. So right here, when R is there, the angle that's formed has got to be less than 90. But if I look at that middle point, I know PQ is 8. Let's say it splits it down the middle. I know that's 3. So this has got to be 4 if it's split down the middle. Do some a squared plus b squared, and I find out this side is 5. So since the side lengths, since here's the right angle, the other side lengths are 3 and 4. I know if those 2 side lengths were the same, then those 2 would be 45-degree angles. However, since they're different, and this angle is across from the longer leg there, I know that this angle has to be greater than 45. And same with right here. That angle's got to be greater than 45 degrees. Therefore, the entire angle has to be greater than 90 degrees. So here is where my point is coming in. So we know when that point is in the middle, obviously R can't be there because that angle would be more than 90 degrees. What I'm going to say here is, here's, again, P and Q. I'll erase that. It's still 8. So right here, remember how we noted that that angle is less than 90 degrees? If we keep moving along, like if we keep moving along this line, so like right here, maybe it's not quite, it's moving toward being greater than 90 degrees, but it's not quite there. It's got to be true that I can draw an angle somewhere, and let's say it's right here, such that that angle is going to be 90 degrees because it's moving from an acute to an obtuse when it hits the middle, that at some point in between there, it's going to pass through, making this angle a 90-degree angle. Therefore, that angle has to exist, and it also has to exist right here. R's got to be there. And it's also got to exist down here. And same with right here. So here are 4 more points. And again, reiterating the fact that this height is still 3. All of the points on that dotted line have height 3 compared to the base. So the area is still 12, and it's still a right triangle. Therefore, there are 4 more options. So the total options are 4 plus 4. So there are 8 different places you can put R. And so that is choice D.